few why questions here that I think we should discuss. This is, take for instance, this is a why question. So let's check how this one would be solved. In the diagram below, ABCD, ABCD is a circle, that is a cyclic quadrilateral. Then DAE, DAE, CBE, ABF, DCF are straight lines. As you can see, this, and this. If y plus m is equal to 90 degrees, find the value of x. If y plus m is equal to 90 degrees, find the value of x. Your pencil, let's trace. What theorem can you see here? What theorem can you see here first? Let's see the theorem we can achieve here. I see some angle theorems and plane geometries here. I think I'm going to use it. This one is vertically opposite to this, so this is x. Yes. And this one, x and y, x plus y here will be equal to this angle. They call it exterior angle is equal to sum of opposite interior angle. So the exterior angle here is equal to sum of opposite interior angle. So this one will be equal to addition of this and this. So I can call this one x plus y. That is your second theorem in triangle. Please note that. So we have, if that is the case, this one too, this angle outside will be equal to y plus m. That means exterior angle is equal to sum of opposite. So this one is m plus y plus x as well. Sorry, m plus x as well. Look at it. That's what I'm saying. So if I can, this one and this one will be equal to 180 degrees. That means that because they are cyclic, then I can have our work from there. So from here, let me write. Then this angle ABE, right now, angle ABE, this angle is equal to x. Why? Vertically opposite angle. So, and I have this one, I label this one. So x plus y will be equal to this angle, that is DCB, y, exterior angle of x and y. So from here I think I have this one too. My DAB as well would give me m plus x, y, exterior angle of m and x here too. So from here I can proceed by saying, therefore, m plus x plus y will be equal to 180. Cyclic quadrilateral. So I will have 2x. I will have, let me continue from here. I will have 2x plus m plus y is equal to 180 degrees. Don't forget our y plus m, or m plus y, is equal to 90. That means this I will have, therefore 2x plus 90 degrees is equal to 180. So I have 2x is equal to 180 minus 90. I have 2x is equal to 90 degrees. So x is equal to 45 degrees. That is that. Let me quickly take it again so we move to the next question. This was what we were given. Note that. This was all we had. Vertically opposite angle will give you this. That's primary 5, JSS2 or something. So this one and this one will give us this. That is SS1, second theorem, that says angle outside, exterior angle, if you had the two opposite interior angles. So this is how you identify your exterior angle that you are going to use for the interior angle now. On this straight line, this one is in the triangle. So we have this one and this one and this one in the triangle. So the reflex angle to this one will be equal to its other two. So once we have this, we can, other two. This one will be, so we'll have this one will be equal to this. So once you can take this, leave this one out. If you can leave this one out, you know it is this one that is connected to this. Look at this again. I can relate it here as well. If I have the 1, 2 and the third one here, so the one outside will be equal to this and this. That's why I wrote m plus x there. So from here I had this one and I have gotten this one. I added these two together to give us 180 degrees. That's what I did. That is cyclic quadrilateral. That means the point, the point, the point, and the point. So this one will also be equal to this, but we don't need that. So we are using these two. So you can have other theorems apart from the one I've used. It's fine. So, but this was what I saw first. That's why I was using it, and it's very correct too. So this one, x plus x will give us 2x. Then m plus y is equal to 90. So I was able to substitute this one. Then I got 45 degrees. So that is that. Let's try another question. In the diagram, PQRS are points on the circumference. Obviously, you can identify this one to be cyclic quadrilateral. Let's see if it's going to be useful. But this is 160 according to this, and 45. And what will we have to find? QPS, Q, P, and S. That means this entire angle. Let me call this one X. The first question to be solved. And Q, R, QS, R, Q, and S. That means this angle. Let me call it Y. All right. With my pencil, I can relate this one because it is angle at the center twice angle at the circumference. So I am sure with this to be 80 degrees. Interesting. So if I have this to be 80 degrees, then there is something around this one. This are radii. So definitely whatever thing this one is, this one will be this. So we have 160 minus 180, that is 20, that is 10 and 10. I'm sure of these two. Let's take it gradually, then we will see what we have from there. Okay, so once we have this angle, we can get this angle, everything there. We can get this angle here. And we have been told that this alone from here to here is 40 degrees. So we can get this angle. So this is 125 from 180. That is more like 55. This is 55. If you subtract 55 from 40, that means we have 15. So my y is 15. So let's see how I get my x. I get my x, and that was what I was supposed to get first according to the question. Unfortunately, I saw 15 first. I saw y first. So that is the beauty of the work. It depends on what you see. So work according to what you see, and you should definitely see something. So if you are not seeing anything, you need to go through your theorem again and practice them. Practice your theorem. That means you have not been doing exercises very well. So you need to do as many exercises as possible. So let's see how this goes. I have this one to be 10 and this one to be 10 now. So from here, I have this to be 40. Beautiful. So this one is obviously known. Some of angle in triangle. See me? I was supposed to get this one first before this. That's the beauty. Like I said, it depends on what I saw. So I saw this first, but looking at this, it looks like I should have seen this one first because it's a triangle. Let's work. Angle at the center twice angle at the circumference. So we have PSQ. PSQ is going to be 160 divided by 2 angle at the center is equal to 2x angle at the circumference. So we have PSQ, that means equals 80 degrees here. So once we have 80 degrees here, and this has been given to be 40, therefore to get x first, I will have 80 plus 40 plus PSQ or QS, let me say QSP. I mean QPS now. QPS, this angle is equal to 180 degrees. Why? Triangle. So I will have 120 plus QPS now is equal to 180 degrees. So I will have QPS is equal to 180 degrees minus 120, that is 60 degrees. So this is 60 degrees. So to get our y, if this is 80, our PS, that is second one now, this is the first one, PSR, this angle is equal to 125. That means 80 plus 40. Therefore, we can get this one, that is PQ and R. PQ and R will be equal to 180 minus 125. Why? Cyclic, quadrilateral. So we have PQ and R is equal to 55 degrees. That means everything here is 55 degrees. So, and 55 degrees is a combination of 40 and y. So 40 plus y will be equal to 55 degrees. So y, or you call it r according to the question, qs is equal to 55 minus 40. That is 15 degrees. That's all. You have your full mark. Let me summarize. This was what we were given. We were never given this. And in fact, do you realize I didn't use this 10? I only gave you an opening. So to whatever thing you can see there, okay, this was what we were given. This was all we were given. So we had been given this one to be 40 degrees. So QPS, that is QPS, that is this angle, I called it X. And my RQS, this angle, I called it Y. I called it Y. So if I should have these two as X and Y, then we should look into this. So this is angle at the center, and I found angle at the circumference, fortunately for me. So this one is 160, this one is 80 now, divided by 160, that is 2 divided 1 divided by 2, that is our theorem 2 that says angle at the center is twice angle at the circumference. So if you don't get that, you have to go through the videos that have been posted to check those theorems out. So once we have gotten this is 40, this is x, then this is a triangle already. So 80 plus 40 plus this will be equal to 180. So we got this one to be 60 degrees from angle and a triangle. So if this one is 60 degrees, we are good. So combination of this will be supplementary to this. So this one is supplementary to this. How is it supplementary? Quadrilateral. That's a quadrilateral. We have discussed that theorem too. So this is 125, sorry. 125 minus 180, this one is 55 degrees now. So far this one is 40 degrees, then take 40 from 55, you have 15 degrees. That was what we did there. So before I give you classwork, can I treat one more question, please? If I'm sure you are not bored. Let's treat one more question, then we call it a day for today. Calculate the value of x. We are solving for x. Solving for x. So we have x here, I have 2x here, I have 60 here. That's all we were given. So let's see with the pencil, let's see what happens here. Well, I can see cyclic here. So whatever thing is here is what we have here. Oh, great. I have this exterior angle here, which is opposite interior angle. So this one is 60 plus x. Good. So this question is very easy. So we have 60 plus x, and this one together is supplementary. So we have this one to be 180 degrees, then we get our x. So this is easier than I expected. So I was thinking I could use 120 here, then this one is 60, then, but I realized it's not necessary now. So let's work. So this one, 60 plus this side now, that is DCB, angle DCB is equal to 60 plus x. Exterior angle is equal to sum of two opposite interior. So Once we have 60 plus x here, therefore 2x plus 60 plus x will be equal to 180 cyclic quadrilateral. So I will have 3x is equal to 180 minus 60. So let me rewrite this one here. I will have 3x is equal to 180 minus 60. Then we have 3x is equal to 120. Then x is equal to 40 degrees. Game over. Problem solved. That's all. That's all. So let's see if you can solve some. Of course, you should be able to solve some exercises correctly. But let me give you the questions. So look at this question now. Let me explain what I have here. Number one, I have a diameter. You can see the diameter. I'm just showing you the diameter. I have x here, 36 degrees here. Then everything here is y, and everything here and here alone is 38. So we are solving for x and y. We are solving for x and y. You can see theorem, diameter is there. I have same segment here, same segment here. You're fine. Then cyclic quadrilateral is there. Play around those theorems, you'll get your answer. And for this one, I have cyclic quadrilateral, another cyclic quadrilateral. Then I have same segment, angle in a straight line. You are fine with these two. So you are solving for x and y here. This one is 115 degrees, this is 85 degrees, this is z, and this is 75 degrees. For this question, please pay attention. This is 110, this angle alone. This is x, and this is parallel to this. These are hints. It's going to help you. This one is parallel to this one. So this angle is z. You are solving for z2. This is 35 degrees. This is y, and this is x. So that is the classwork I have for